the ticket.
The outdoor channel is on Cable 1 Channel 305.
We now return to magnets on Modern Marvels. No device illustrates the march of miniaturization and advances in magnets better than the cell phone. When retailers unveiled the first generation of models in the 1980s, they were as big as bricks and just about as heavy. Over the years, smaller and smaller transistors helped designers create phones with footprints no bigger than a business card. But without a tiny rare earth magnet for its speaker, a model this petite would never have been possible. Rare earth magnets were first developed in the 1970s and 80s, derived from a group of scarce metals that until that time were very difficult to refine.
They've found that adding these metals to samarium and cobalt together make a very powerful permanent magnet. These are extremely strong. If you take a magnet made of samarium cobalt, just 3/8 of an inch square, and you bring them together, you physically have to work very hard to pull them apart.
The mighty and minuscule rare earth magnets have helped power the age of mobile computing. They're an integral part of every laptop's miniature disk drive. The relationship between magnets and computers dates back to the 1950s, when scientists explored the idea of using magnets as repositories for information.
A North Pole up gives one measure of something. A North Pole down gives another measure of things. And once we can say this is yes and this is no, then we can build a memory device out of it.
Most computers today come equipped with hard drives featuring a layer embedded with tiny magnets. The north-south configurations of those magnets contain encoded information.
The hard drive is magnetic. There's a read-write head in the computer that rides just above this rotating disk, and as it rotates, it writes and reads little bits and bytes of information on that disk. It could be a south pole, and next to it, it might write a north pole, so you'd have a 1 and a 0.
Ones and zeros are the components of the so-called binary language of computers. What would appear to us as an ocean of indecipherable numbers contains data easily digestible by the computer's processor. Magnetic hard drives, however, retain only part of a computer's data. Semiconductors provide its primary memory, in which most of the computing takes place. The semiconductor memory, known as RAM, is faster, but carries a distinct disadvantage. When you shut off the power, the data disappear. Rebooting your computer takes several minutes because it's reloading the lost data onto the memory chips. Researchers, including MIT professor Carolyn Ross, are searching for an alternative, using magnets.
The next big thing that's coming along is called MRAM, that's Magnetic Random Access Memory, and what that is a magnetic chip that you can put in your computer, and it acts like the memory chips we have now, except that when you turn the computer off, the information stays there, and so when you turn the computer back on, all the information is still there and the computer comes on immediately without having to wait for it to boot up.
To determine which magnetic material might make the best MRAM chip, researchers place samples in a machine called an alternating gradient magnetometer.
This machine has a couple of big magnets. These are electromagnets. So we pass a big current through some coils, and that produces a magnetic field. And it characterizes the magnetic properties of a material, so we can assess whether that will be a good material to use in an MRAM or a hard disk, or other applications like transformer cores, which all use magnetic materials.
As the quest for MRAM continues, researchers at Ohio State University are exploring an intriguing alternative. They've created an unusual magnet that also promises to start your computer in a flash. It's made not of iron or steel, but plastic.
Presently, plastic magnets remain sensitive to the air. So in our research and our development, we keep our plastic magnets in environments which have no oxygen and no moisture.
Researchers produce the plastic magnets by mixing two chemicals, vanadium hexacarbonyl and tetracyanoethylene.
What I have here is the vanadium TCNE that's been deposited on a piece of Teflon tape. The easiest way to tell if it's magnetic or not is to stick it next to a magnet and see if it attracts.
Ohio State's research teams have learned they can manipulate the strength of this magnetism using surprising new methods.
With plastic magnets, you're able to control magnetism in ways we can't control it with conventional metal or ceramic magnets. The plastic magnet has a structure we can address with light.
Experimenting with lasers, the researchers have found they can alter the strength of plastic magnets using different colors of light. Blue light increases the magnet's strength by about 150%. Green light has the opposite effect. It reduces the magnetism by about 60%. Such results hold the promise of recording and reading digital information in a revolutionary new way.
Plastics that are magnetic opens up the opportunity for new kinds of technologies that will have computers that turn on instantly, low-power electronics, lightweight ways of storing information.
Experts are confident that magnets will rise to the occasion in all fields of scientific endeavor. Some of magnetism's most intriguing applications are totally up in the air. In 1956, IBM introduced RAMAC, the first computer system to use magnetic disks to store data. It required 50 24-inch disks to store 5 megabytes, about the same amount of memory needed for a typical MP3 song. Magnets will return on Modern Marvels.